In this lesson, you are going to learn on how to calculate the number of ions from a given amount of a substance. Let us start with the first example here. It states that calculate the number of ions present in 1.2 kilogram of sodium carbonate. Now, let us see the solution. Here, we have the number of steps to follow whenever you are given the amount of a substance and you are told to calculate the number of ions present in that amount. The first step here is to calculate the number of moles of a molecular substance. As you see here, the first step is to calculate the number of moles of a molecular substance. To calculate the number of moles here, you have to know that is equal to the mass given over molar mass. Now, we say that number of moles is equal to mass over molar mass. The mass of sodium carbonate given is 1.2 kilogram, which is equal to 1,200 gram. Now, it is equal to 1,200 gram of the molar mass of sodium carbonate, which is 105.988 gram per mole. Now let us compute the value obtained after taking the mass over molar mass. When you take 1,200 gram over 105.988, you get the number of moles is equal to 11.322. Now, we've obtained the number of moles of a molecular compound before dissociation. The second step is to write a balanced dissociation equation. As you see, this is a dissociation equation. Sodium carbonate dissociates completely to form sodium ion and carbonate. After that, let's balance this equation. On the product side, you have one sodium, but on the reactant side, you have two atoms of sodium. So let us multiply this one by 2, so as to have 2 ions of sodium, as we have 2 atoms in the reactant side. After that, let us balance carbon. On the reactant side, you have 1 carbon atom and 1 carbon in the product side, so it is balanced. In the case of oxygen, we have 3 atoms of oxygen in the reactant side and we have 3 oxygen in the product side, so they are balanced. Now, we have finished to balance. A third step involves the conversion of the number of moles of a molecular substance to the number of moles of ions. To make this possible, we use the mole ratio from a balanced dissociation equation. From a dissociation equation, we find that 1 mole of molecular sodium carbonate dissociates completely to give 3 moles of ions. As we find here, we have 1 mole of carbonate and 2 moles of sodium, so it makes 3 moles of ions. Now, 1 mole of a molecular substance dissociates completely to produce 3 moles of ions. So, from a balanced dissociation equation, we find that 1 mole of sodium carbonate dissociates to give 3 moles of ions, as we see here. Now, how many moles of ions are there within 11.322 of a molecular sodium carbonate? Now, how many moles in 11.322 moles of sodium carbonate? After crossing multiplication here, to get the value of X, which is equal to the number of moles of ions produced, is equal to 11.322 times 3 over 1, which is this one. Now, our value of X will be equal to 11.322 times 3 over 1. And when we divide by 1, you get the same value. Now, let us compute this. After multiplying, you get 33.966. These are the moles of ions. Now we have obtained the moles of ions from the number of moles of a molecular substance. The next step here, which is our fourth step, is to calculate the number of ions from the obtained number of moles of ions. It is simple. You just take the number of moles of ions times Avogadro's constant. So we take the number of moles of ions obtained, which is 33.966 times Avogadro's constant, which is 6.022 times 10 raised to 23. Now let us compute to get the number of ions. We get that the number of ions is equal to 2.0454 times 10 raised to 25 ions. So the number of ions present in 1.2 kilogram of sodium carbonate is 2.0454 times 10 raised to 25. After that, let us go to the second example. The second example states that calculate the number of chloride ions present in 3.8 moles of iron 3 chloride. For us to be able to calculate the number of chloride ions present in this amount of iron 3 chloride, we should follow the following steps. The first step is to write a well-balanced dissociation equation for iron 3 chloride. As you see here, iron 3 chloride dissociates completely to form iron 3 ion and chloride ion. Now, let us balance this equation. Here, on the reactant side, you have one iron and one ion in the product side, so it is balanced. Also, we have 3 atoms of chlorine in the reactant side, and we have 1 ion of chlorine in the product side. So we should multiply chlorine ion by 3 so as to make 3 ions of chlorine, as we have 3 atoms of chlorine in the reactant side. Now our equation is well balanced. After that, let us go to our next step. This step is to convert the moles of molecular compound to the number of moles of ions. You have to remember here, the task which we have is to find the number of chloride ions present in 3.8 moles of iron 3 chloride. And we are not told to calculate total number of ions after dissociation. We are going to deal only with the chloride ions. So, from a standard balanced dissociation equation, we find that 1 mole of a molecular iron 3 chloride is equivalent to 3 moles of chloride ions. That is why I have written here 1 mole of iron 3 chloride is equivalent to 3 moles of chloride ion. In this ratio, I have not included iron 3 ion because we are not asking to deal with iron in our question. That's why I have dealt with the only chloride ion. So 1 mole of iron 3 chloride gives 3 moles of chloride ions. Now, how many moles of chloride ions will be in the given number of moles? Now let us cross multiplication. Now, after crossing multiplication, the number of moles of chloride ion which will be in 3.8 moles of iron 3 chloride will be equal to, I have termed this number as x, so our value of x will be equal to 3.8 times 3 over this number over 1. What we get here is known as the number of moles of chloride ion. Moles of chloride ion. Now let us compute to get this number. After computing, we get equal to 11.4 moles of chloride ion. Now we have obtained the number of moles of chloride ion in 3.8 moles of iron 3 chloride. But we are required to calculate the number of chloride ions and not number of moles. So the next step here is to calculate the number of chloride ions present in the obtained number of moles of chloride ion. As I have written here that a third step is to calculate the number of ions from the obtained number of moles of ions. How do we do this? To get the number of ions, we take the number of moles of ions times Avogadro's constant. This will be equal to 11.4, which is the number of moles of chloride ion, times Avogadro's constant, which is 6.022 times 10 raised to 23. After multiplying these two values, you get 6.8651 times 10 raised to 24 chloride ions. So we may conclude that when 3.8 moles of an-ethyl chloride dissociate completely, it gives 6.8651 times 10 raised to 24 chloride ions. This is the answer. After that, I take this chance to thank you for attending today's session. I welcome you in the next sessions. Have a nice moment.